Okay, so this paper is about language model agents, or this tutorial is about language model agents. Kind of a funny thing, I've got a paper about this, and you know when you're doing a paper, you kind of do the introduction bit really little, and then you're like, oh, here's all of my clever things I'm going to say about it. And then when you're doing a tutorial, you write, oh yeah, I've got to kind of reverse the order of those two things and say a ton about all the introductory stuff, and then only a little bit about the, the clever things that I think about it. But the fun thing was that it kind of made me get into some stuff that I've been kind of taking a little bit for granted and dig out of that. So I want to thank especially Steve and Casper here for helping me out with this, and also Aaron Snorswell back at QUT. All right, let's get cracking. So during the course of the discussion, if you wouldn't mind passing that around, we don't have a way to add this to the slides. There is a Slido, which will have the opportunity to do a certain amount of Q&A as you go along. So, and if stuff keeps coming up that I'm not explaining properly, then Kaz will let me know and kind of grab my attention. And then obviously we'll have like a normal Q&A at the end. All right, so let's start. There is a new race happening towards language model agents. LLMs can use tools, they can do a certain amount of reasoning and planning, and they can take relatively long sequences of independent actions. I'm going to talk about precisely how in a moment, but this is just to kind of get us all on the same page. There's lots of different versions of this. There's like the open source platform approach that LangChain are taking, where they're trying to create sort of an architecture or framework through which people can build language model agents. There's private things like the GPT store, which is almost at the rest in peace stage, I think. Like it was a bold notion to kind of capture the market of language model agents. Away from there. But at the same time has sort of not really had a ton of uptake. There's things like these companies like Adept and Imbue, who are trying to do this as kind of startups, basically to kind of reinvent the way in which we interact with digital computers. So using language models to create agents to perform all of the functions that you would do with digital technologies in general. The aircon is so loud. Like, it's really bananas loud. Are people also not cold? Would it be the end of the world if we turned off the aircon? Can we do that? Yeah, would you mind? Can we turn off the aircon? I can hardly hear myself think. It's like having a sort of a plane take off in the middle of the room. Yeah, okay. Very cool, interesting stuff. Like Adept is one that was founded by one of the authors of the Attention is All You Need paper. Okay, so like with a lot of stuff about LLMs over the last year, it's been super clear that there's a lot of descriptions of capabilities where really they aren't sort of fully well established. But I want to emphasize this is not an area where there's only promises. There's real stuff happening here. It's all right, you're okay. Still just letting the ground. There's real stuff happening here. This isn't just promises. It's also not only software, for that matter. It's actually robotics as well. So some really cool examples here. I love this one. The Red Dead Redemption one. I play Call of Duty a lot, and the bots suck. Like, they're really annoying. They're either just too predictable and useless, or they are way too fast and way too hard to beat. This Red Dead Redemption one is like, they basically trained a language model to sort of monitor a screen of a game and then use the keyboard in order to do inputs and mouse. Not obviously literally use the keyboard to do inputs and do the mouse. But can play Red Dead Redemption really well, okay? Like, this is a pretty complicated task for an agent to be able to do. Okay. Devin is a software engineering agent developed by Cognition Labs, who now have a massive investment from Microsoft, which has so far been the most sort of functional kind of agent that's been generated. Can take tasks off. Yeah, thank you. Oh, no.
Split up? Yeah.
Almost. Yeah, so Devin is a really cool software engineering agent that can take tasks from Upwork and complete like some number of them. Not like all of them, but a good 12, 13%. Oh boy. Thank you. I'd love to. I'll keep using the mic if anyone is, just for the 3 people who are streaming. So Devin, very interesting, obviously not perfect, but like pretty impressive. NVIDIA have this lab that works on agents called the Gear Lab, led by Jim Fan. They've got this model they call the group model. There's robotics companies like Figure, Tau, Astrobot. There's things are happening in the world of agentic AI. What do we think is going to come? So I'm going to talk a lot more about this, but this is just to give you a sense of where we're headed. I like to think in terms of like leading indicators, next generation, and then what comes in the future. Really, huge recommend for this podcast, Latent Space's episode on the truth of not safe for work AI. Like one of the things anybody who studies technology knows is that very often the porn industry kind of takes the next step in digital technologies that then gets kind of propagated out through other areas. So that might be video compression, or it might be recommender systems. In this case, it's the constructing of AI agents. Like so, with Latent Space, with this company that was interviewed in that podcast, what they've basically done is they've built a kind of an agent that represents a creator, right, on like an OnlyFans type site. So a task that was previously done by sort of a call center in the Philippines, which is in the specific case, is now done by a software system that involves using LLMs to have a conversation with a customer that is kind of in character, like has to be really important, that has to be on brand for that particular creator, has really hard guardrails, because people might ask all sorts of things that the creator would absolutely not want their kind of representative to say, so it has to be able to apply really hard guardrails. It operationalizes a model of the customer, so it sort of predicts what the customer wants, and then operationalizes that in order to then sell them content. And this actually is a very complex agentic workflow that's been developed for this particular function. We're going to see way more of that. We're obviously already seeing advanced AI assistants, which I'll talk about a bit later. I think that the whole kind of AI companions scene is going to become much more agentic. So at the moment, you've got sort of basically turn-taking dialogue partners, but I think that's going to get much more creative, much more like the not safe for work AI example. So anybody who's heard of Replica, for example, or Character.ai, like people are spending hours and hours engaging with these digital companions. I think that we're definitely going to see task-specific co-workers. So the thing at the top there, top right, as you look at it, was the comment from the folks at Klarna, where they talked about using an AI assistant was enabling them to get rid of a significant proportion of their customer service chats. And then the next generation, I call these universal intermediaries, this notion of like having your every connection to digital technology be mediated through an agent. I did these lectures last year. I've got a book coming out on it talking about algorithmic intermediaries in general. This is sort of the apotheosis of that. And it's the kind of goal that companies like Adept and Imbue are aiming at. There's some interesting reflections on, there's Project Astra is the kind of the Google attempt to do this. They helpfully called it a universal AI agent. So where does this go in future? Interesting paper here. You can't really see the title. Got to hold the microphone over here. Large language models as agents for augmented democracy. This is a kind of bananas thing, but this guy, Cesar Hidalgo, has done lots of really interesting and very creative and sort of unrealistic work about the prospects of using computational tools to enhance democracy. In this case, the notion being having an LLM agent that represents people. Lots of questions about it, but it's an interesting one. But then the next kind of step that we're kind of headed towards, in my view, is that we're headed towards a situation where you basically have the capability to have agents that take on kind of arbitrary tasks for you. That's what I mean by an arbitrary proxy. All right, so what do we need to know? Which is basically going to be what am I going to talk about here? What do we mean by agents? It is among the sort of AI engineer crowd, it is the most abused and like a derided term short of alignment, I think, that there is. So let's try and pin down what we mean by it. Not in a super like term policing kind of way, but at least for the sake of focusing our attention. How do they work? Like I know that there's a range of different kind of technical backgrounds in the audience. For some of you, that part of it will just be very obvious. For some of you, it might be useful. What should we expect the societal impacts of language model agents to be? What norms should we want to align them to? Do we know how to align them? And is that term even useful? And then how should we govern our language model agents? Okay, so we'll go through all of these things. I'll try and sort of pause at the end of each substantive section so we can ask questions. You can ask questions about it. I haven't taught for a very long time, so like doing a tutorial part of this, like if you're getting restless and I'm being annoying, then just put your hands up in any case. So let's start. All right, what's an agent? Glad I didn't put any animations in these slides, given it's PDFs. I could spend a long time on animations. Okay, hands up in the room. Who's a philosopher? Who's got philosophical training, if you like? Okay, so you guys are going to have to chill for a bit. All right? Because I'm not going to talk about agency in a way that engages in a deep way with the philosophical literature on agency. Essentially, like, I'm not going to talk about what grounds agency. I'm not going to talk about the difference between simulating agency, being an agent. What I'm going to give you quite a functionalist account of agency. So I'm going to talk about properties that agents have. And in my view, like, the best way to think about this is to think of agency as being this kind of multidimensional thing, where there are lots of different properties that relate to agency. And I've listed a bunch on the next slide, but like, I'm sure I've not listed all of them. And the thing to remember is, like, we talk about an agent like it's a unitary thing. In my account, like, I don't know, maybe there's a sort of a thresholding over the multiple dimensions such that something above that threshold counts as an agent. But also maybe not, like, maybe there's just lots of different ways in which a system can be agentic, and some are more agentic than others, and like a thermostat might be agentic in a very minimal way, and a human who is in sort of difficult circumstances might be agentic in a different way, and a human who's very lucky and who has access to lots of resources and options and can choose among them could be agentic to a different degree. Like, these are things that just kind of, with a multidimensional property that is degreed in each of its dimensions, you're going to get all sorts of interesting combinations. I did think about trying to do a radar chart, but then all the lines got stuck underneath one another, and data visualization is not my strength, and also I was only on an iPad, so like, instead. All right, this is not the only slide with properties of agency on it. I have another slide, so don't think this is all of it. There's more, there's lots. Okay, and it's also actually, I've written it, I now realize that writing this all out as a sentence with multiple clauses was a bad idea. But anyway, hold the multiple clauses in your thought. Like, an agent is a system that has these properties, okay? So one, it shouldn't, there's a dimension of being, not being subject to immediate, exogenous, intentional intervention. As many syllables as I could cram into one line. The point there being that basically, like, one thing that makes you agentic is that you're not just kind of being pushed into doing something. So like a system that is kind of like a turn-taking dialogue partner, like a ChatGPT, requires intervention at every moment. Like, it will respond to you when you say. If you don't kind of give it a prompt, then it won't say anything to you, right? So that's a very sort of minimal degree of agency. Another system might be able to kind of complete, like, we as humans, we wake up in the morning, we self-actuate on good days. And that's something that, like, is a kind of reflective of our independence, right? Okay? In this very narrow sense. And all of the terms I'm using here, I'm stipulating their meaning as terms of art for this particular purpose. They're the terms that seem most accurate for what I was describing. Okay, without an exhaustively pre-programmed script, something that makes you less autonomous is that you are kind of only following a particular script that you cannot deviate from, right? So if you think about, like, a thermostat or a software program in general, these are things that, like, even to a certain degree, the Not Safe for Work AI agent, which has, like, the state transitions are handled by the programmer who is kind of setting things up in advance, right? There is a kind of, like, a script, but there's not as much of a script as there is for, like, an ELIZA-type chatbot, right? Where it's basically just predetermined, like, you put in this particular input, you're going to get this particular response, okay? So that's another element of it. I call that autonomy in a very, very specific sense. Just you're not subject to this pre-programmed script. In a wide range of scenarios. This part is really important, adaptivity. Like, agency is partly a function of your ability to adapt and operate in different settings, right? So the thing that's cool about language model agents, as I'll say, is that you don't necessarily have to kind of keep them narrowly focused on a particular setting. So take something like Cicero, which I'll talk about a bit later. This was the meta system that was developed to play diplomacy, right, and achieve this online game diplomacy, achieve, like, a sort of performance of, like, top 10% of players in the world at a certain format of the game. I think it was like a 15-minute version. And like with lots of reinforcement learning-based agents, like I'll say in a bit, like, it's not very adaptable to different circumstances. Like, you change the parameters of the game a bit, and it falls apart, right? AlphaGo 0, similar story. Like, amazing at playing Go on the standard board, change the number of tiles, whatever it might be, move out of the parameters it's training, and it can't generalize to that. Adaptivity is a really important part of agency. Of course, in order to act in all of these different scenarios, you have to be able to perceive relevant features of those settings, right? So that ability of perception is also a crucial part of agency. You can imagine something that is kind of functional in all of the other dimensions, but just is, like, blind and therefore won't be sufficiently adaptive. Some of these may slightly overlap. Optionality is a big part of agency. This, I'm actually thinking here, like, substantially in terms of this kind of derives from Joseph Raz's theory of autonomy, which basically argues that, and so here the philosophers can prick up their ears again, basically argues that like you are more, you have less autonomy in that context if you have fewer options. Like so, if you like being able to choose uninterrupted or uninterfered with between A and B is not sort of reflective of your autonomy if A and B both suck, right? And I think that like when we're designing AI agents, we're going to see like systems that have more or less agency, right? More or less optionality. So, ChatGPT right now has like a few options it can do. It can search Bing, it can run code interpreter. You can give it particular functions. You can expand its optionality by enabling it to do different function calls. Okay, still more properties of it. These are all things that make something more or less agentic. Like being able to affect the world to a greater or lesser degree. I think that, well, I was going to say a butterfly, but then I thought, oh, well, but the butterfly flaps its wings, and then, on the other side of the earth, the Great Wall of China falls or something. But in general, butterflies can't make much difference in the world. But humans, us, we can. Like among different types of, the thing that's interesting about language model agents versus language models is that like we're purporting or we're planning to enable them to do stuff in the world. So Devin can solve software engineering problems, can take tasks from Upwork and resolve them 1 in 10 times. That's like a significant degree greater effectuality than just like solely being able to produce text, especially if you're only producing text that nobody's reading. There's sort of infinite backroom style things there. Okay, another really important part of agency is the ability to respond to reasons. Okay, this is sometimes presented in standard computer science thinking. This is often thought of as being about just kind of optimization. Right? What you're essentially just doing is kind of optimizing some particular function. But like that's like one type of rationality, like maximizing something. It's not the only type of rationality. Like rationality is just about responding to reasons appropriately. So this might be recognizing like rights, for example, or constraints on your behavior. It might also be recognizing that there are particular features of a situation that are worth paying attention to as you make your decision because those features ground reasons. I'll talk a bit more. And obviously, like in order to be able to do all of these things in a dynamic setting, that reminds me that I didn't mention the kind of the planning part, the long sequences part. Yeah, being able to do things long sequences of actions, really important. In order to be able to do that, you need to be able to update on the basis of what you've done before. So again, like this is a standardly sort of theorized thing within reinforcement learning, the way in which like an agent will kind of update on the basis of the ways in which its environment changes and then sort of choose its next action accordingly. This is also obviously something that we all do regularly. And keep track of what you've experienced. So the less you have kind of memory, the less you have any sort of continuing identity, I think that also reflects a kind of a lesser degree of agency. Okay, so all of these properties are all relevant. And like before language model agents, basically this is as far as we've got. So let's talk a bit more about reinforcement learning agents. The picture there is Cicero that I mentioned before. This was kind of like the state of the art in AI agents before we got to language models. They're pretty independent. They don't rely on a completely exhaustively pre-programmed script. They are good at planning, like that's definitely a strength. Like the whole kind of process of reinforcement learning is fundamentally about sequential decision making. They are good at perception within a particular domain that they're trained on, and they're good at updating. So they can do like really good games like diplomacy. They can perform really well at because of all those functions. But you do have to train them for the very specific task that you want them to perform, and so they can't really. Like, relatively speaking, they can't really adapt to unanticipated choice situations. If it wasn't part of the original kind of, whether it's self-play or other types of training, they won't be able to do that. So their perceptivity and their optionality are limited, and so, yeah, they would be rubbish at diplomacy if you change the rules a bit. Also, their rationality is very narrowly instrumental. It's all about optimizing some particular function. They're maximizing reward. Of course, it's fun. They're minimizing loss, maximizing reward. They can't directly act on non-instrumental reasons. So, again, one for the philosophers, they are little mini silicon JJC smarts, like real simple utilitarians, basically. So obviously, it's no surprise, given all these limitations, that people have been looking for some kind of alternative or perhaps complement. So, how do we get there? How do language model agents work? All right, yep. Yes, yeah, good. Mm-hmm.
So I'm glad that I think the well interpreted definition of intelligence is basically a feeling that can kind of take action without needing to satisfy your goals,
Yeah.
right?
So I'm trying to sort of explode out some of the elements that are conflated within the, yeah. Yeah, I'm trying to explode out. So the question is basically like the standard approach to thinking about intelligence is being able to kind of act adaptively to optimize for some particular function for your goals, one might say. I don't think that that doesn't contain a lot of content. So I'm trying to kind of explode it out to all of these different elements that kind of enable agency. I think that using the concept of intelligence in that context is a term of art, and it's fine. And I'm sort of I'm invoking agency here as a somewhat different term of art. And I think that the key thing is to sort of stipulate what we mean by those different terms. So, so I'm not going to talk about what intelligence is. So in that context, agency is this multidimensional thing. If you think that intelligence describes that, that's okay with me, but I'm not going to try and kind of do that part of the conceptual analysis. Right? So these are the properties that I think are important for thinking about language models, yeah. Oh.
Something that strikes me is that none of the properties explicitly relate to relationality, like relations. So relationship either with other entities, other agents, or the world around them, other than maybe perception. So yeah, maybe what's the view?
I'm not sort of. Well, have you seen the episode of Blackadder where Blackadder meets Samuel Johnson? So Samuel Johnson says that he's just completed his first English dictionary, and he's like thought of every word in the English language. And Blackadder takes great delight in like coming up with words that aren't in his dictionary, and Samuel Johnson gets progressively more irritated as Blackadder does it, like says carrot or whatever. So this is not a Samuel Johnson enterprise. I'm not trying to do an exhaustive taxonomy. So there may well be plenty of other things that fit into into these buckets. Personally, I actually think that the things you're describing are actually captured by instrumental and non-instrumental rationality. So I think you're talking about reasons that we have to respond to certain types of relations. And so I think that would be a subset of possibly mostly non-instrumental reasons.
Can I do another response? And I mean, like moving away, I'm not trying to punt for like a complete taxonomy. Maybe where the question came from is that in, let's say, some animal studies that were done, there were decades of studying animals where people looked only at individual animals. Mm-hmm. And the moment people started studying relationships between, for example, baboons or so, it completely changed their perspective on how individuals interact, like what individuals did and what motivated them and so on. Yeah. And so maybe it came more from that perspective of saying, I guess scientifically we've got a history of valuing the individual entity, mm-hmm. not necessarily always the relations between entities, but a lot of the drivers of behavior are relational.
Yeah, so I'll come to something in that sort of vein. I think it's a nice point. And I think like one of the things I will talk about a little bit is like in the absence of a kind of a natural kind of biological body, what are the boundaries between agents anyway? Right? This is what I meant by sort of invoking memory a little bit. It's like insofar as we're thinking about something that is unitary, we have to have some sort of criteria for consistency over time that like constitute an individual entity. And like there's no reason why we should expect that to be the same in this case as we do for sort of our standard like anthropocentric model. That's just I think a good thing to pursue, and it leads to some interesting normative questions later. All right, so we've talked about why reinforcement learning sucks. It's because they're all consequentialists, and reinforcement learning is full of jack smarts. I speak as someone who's like, I'm in Australia, and there are just lots of simple utilitarians all around me, so just like lots of little reinforcement learning agents everywhere. Okay, so how do language model agents work? So basically, these are still language models. They are still producing text. That is the kind of the central thing that they do, their core constituent action. But obviously, you can use text to do a ton of different things. For me, the kind of penny-dropping moment here was the Timo Schick paper, Toolformer, which is really worth reading. There's also the FAccT paper. These two sort of differ only in as much as the Schick paper talks about how you can fine-tune a language model to make function calls to different software APIs and thereby take actions. The FAccT paper is all about, basically, it's zero shot. It's prompting the language model to do these things. In both cases, what you're doing is you're getting a language model to call a software API to then take a set of actions that kind of could be any kind of actions, right? Because you can use software to do a really wide variety of things. And they're just kind of really quite good at it, at least in the single case, much more than you'd expect. And one of the things that's kind of cool about it is that everybody knows that language models have lots and lots of shortcomings and failures and failure modes. But it's possible to train them in such a way that they recognize when they're in one of those possible failure modes, and they call on a different tool in order to perform that. So in the tool former paper, it was just a simple one. It was like being able to call upon a clock when you're asked what the time is, as opposed to just sort of confabulating the time, right? But you can do that much more complicated things, and you can use various different things, structured prompting, to tell the agent like what to aim at, how to assess its environment, how to plan, how to update its plan after it is active. Like an agent can be just a really, really long structured prompt to a language model that is then equipped with various different tools that it can use to perform various things. Agents can also be more complex than that, like the not safe for work one that I mentioned, which is apparently 16 different models, a bunch of different state change functions, like a load of other stuff. This is from LangChain. It's quite a helpful little, like a sort of an AI engineer's version in a way of the philosophical thing I did a minute ago. This is like a whole kind of program, and this is the code, LLM call, chain together multiple LLM calls, router, state machine, and agent, and basically decide output of step, decide which steps to take, determine what sequence of steps are available. These are all the different things. Like this is when it's just programmed essentially by a human, and each of these bits is going to the language model doing more and more of these different tasks. So it's sort of self-writing software that is taking action in the world. I'm going to skip this because there's a really interesting question. I'll say very, very brief. There's like, at a certain level of description, the language model agent is reasoning in language, and it is not a reinforcement learning agent, it is a language model agent. At another level of description, the text is actually epiphenomenal, and what's happening underneath is just a bunch of mathematical abstractions, which are actually being guided by a reinforcement learning policy, because a language model is post-trained using reinforcement learning to optimize for certain kinds of elements of human feedback. So there's this an interesting thing, like the level of abstraction at which you think about it. On one level, it's all math. On another level, it's reasoning in words. The meso level is the thing I'm focusing on, and I think it's just like, this is in a way, I'll skip it in a way, I think it's the most important slide, because it's the thing that is most interesting about language models, is that by operating at that meso layer, meso maybe, rather than meso, that meso layer, they are able to kind of reason using language rather than just reasoning through kind of the optimization of some particular function. Now, of course, at a lower level of abstraction, they are still optimizing in some description, right? But the point is that what's happening at the level of kind of what's guiding their action functionally is done through language. This is why they are cool. Okay. Yeah.
Okay, so has it been always the case, like the whole reinforcement learning paradigm was introduced as an agentic paradigm? You have an agent that receives and interacts with environment and then acts accordingly, etc. So I guess then I don't see anything uniquely new here. I mean, we are having more and more fancy AI systems, which has always been the case in history, but you still have the same thing. You still have like a mathematical machinery, and then that is like the basis of the whole thing, and then we analyze it in different ways. So I just wonder if what you are saying here is something unique for LLM agents, or is it all? It has, for me, it has always been the case within AI.
Yeah. Okay. So, like this thing. Okay. So I'm not going to slip this slide. So basically, yeah, like there is a sense in which it's true, and also most of what I'm going to say is going to be true for AI agents. The reason why language model agents are interesting is because we actually have something that has a chance of achieving those different layers of agency that I talked about in a significant way. Reinforcement learning agents just are crap at anything except a very narrowly defined task. So language model agents are interesting insofar as they might actually work. I think there's a separate question about what's interesting about them, like why do they work? And that's what this slide is about, essentially. It's like there is a layer, like I was saying, there is a layer at which this is all just math, and like the language model has been trained against a reward model to optimize for a particular function. And in that sense, it is still just doing the same thing as a reinforcement learning agent. But what's basically happening here is that there's at the meso layer, instead of the designer having to set up like a really task-specific reward function for the underlying agent to kind of operate at, you've got the model kind of itself writing its own reward function through language, right? So there's this layer of abstraction. it's a little bit like, this is not precisely analogous, but it's a little bit like the way in which often language models now, if you try and use something like DALL-E, right, you can put in your prompt for a particular image, and then the language model will take that prompt and it will rewrite it in a longer prompt that will then give you a better result with a resulting image. Okay, and there's a similar thing that's going on here. By using this meso layer of linguistic abstraction, we're able to get a different type of reasoning and a different type of adaptivity out of these systems, even though at the micro layer, at the base, it is still fundamentally just math, right? It's still the same thing. All right, so obvious caveat, like everything in AI, it's crap until it isn't, right? And like, I wouldn't be talking about these things if they hadn't reached a certain point of being worth talking about, but they also still are pretty early days. Here's why they're interesting. Because you're reasoning with language instead of reasoning with math, or math at the bottom, but the meso level matters. You can actually do like real reasoning, that like you know, stuff that we might actually want the language models to do. Instead of having to come up with like some way of expressing this all in terms of an optimization. It's like, oh my God, anyone who's done like cost-benefit analysis for anything, it's like when you have to translate everything into a single currency of reward, you lose so much detail and everything that matters basically, and you get these nutty little JJC smarts. But like language model agents we can use the language, the natural language, to get them to reason however we want to. That is super cool. This means that they're also way more flexible. Right? Language as a medium for reasoning and acting, it's just like, can deal with a bunch of stuff. Like a language model can take a scenario that it faces, represent it in a certain language, and then because it has so much kind of training on various different types of linguistic contexts, it can actually produce actions that are adaptive to that. So it doesn't need to be perfectly task-specific. The perceptivity, I think, is really important. Like, as an example, like if you think of, you know, if you had a bunch of cameras in this room, kind of paying attention to the sort of sending a feed of all of the people in the room to a multimodal language model, it would be able to identify kind of action-relevant features of what's going on, right? So someone's looking bored, someone's leaving, someone's, you know, not to call them out, somebody's just started to fall asleep or whatever it might be. Like, yeah?
Press. Yeah. No, it's if you press the first button, you can.
Oh, okay. No, I won't bother. Okay, thank you though. Yeah, they can update. Well, you don't have to exhaustively prescript them. You know, you don't have to decide absolutely everything. Like, you want like a nice complex prompt, but you don't have to basically decide in advance everything they're going to do. It's always a trade-off. It's fundamentally, the more capable the underlying language model, the less work the programmer has to do. These things will sort of work in tension. We won't see which does more. Planning is you know, they do show signs of impressive planning capabilities given how they were trained on next token prediction. I'll talk about limitations in a moment. And they obviously have like really impressive working memory in the sense of their context windows, and you can extend them to have much better long-term memory as well, right? So they have a lot of these capacities of agency to a far greater degree than anything we've had before. It's not like ChatGPT is an agent, right? Like, it's important to recognize that your original GPT-3 kind of just a pure put in the prompt and out you get is the completion. Like, that's not what we're dealing with here. We've got something that actually can use a bunch of tools. It's, you know, can only affect the world to a certain degree, although sometimes it can get its, you know, it can get Air Canada in trouble by dictating a reimbursement policy that doesn't actually conform to Air Canada's reimbursement policies. We'll talk about that later. But it isn't sort of, like, its script is not narrowly prescriptive. It's quite broad. If you've seen any system messages for these models, you know, they aren't like, here is every different scenario that you might face. They're quite general. And it can use these different tools. I talked about code interpreter. Planning abilities are definitely limited and only really does like sort of turn taking. So, you know, it can make 2 calls to Bing. And if the first one doesn't work very well, and it's Bing, so probably won't. But if the first one doesn't work very well, then it tries the second one, you know? It's a bit of a cell phone, really. They shouldn't show that it's doing the two searches. I think, example, Devin is a really good case. From what I've seen, the discussion of it, as a software engineering agent, it is surprisingly impressive. There's another one called SWE agent that came out of Princeton the other day that may be even better. But these are things where, like, you give the model a problem from Upwork, like some particular kind of software engineering task, and it is able to kind of independently run that task. And, like, doesn't do it perfectly. It's sort of, I think they gave like 13% effectiveness. But that's like, a ton more than anything else that you don't have to narrowly define what's going to do. Okay, so having said the positive, it's worth pointing out that there are people who are very skeptical about the capabilities of language models to generate these kinds of agentic behaviors. I recommend the work of, this is Rao Subrakambampati, and there as well, I think the middle, this paper by Srivastava, Functional Benchmarks for Robust Evaluation of Reasoning Performance. Obviously, Melanie Mitchell is another person who's written about this. There's a lot of skepticism about whether language models are really able to reason and plan. And Rao's stuff is basically saying that, like, give them any kind of even basic block swirl type planning problem, and they will basically crap out and just not perform. And like the work of Srivastava and Melanie Mitchell is generally in the realm of this work that's called this paper that's called Embers of Autoregression, which was a fun like little throwback to the Sparks of AGI paper, and it was like Sparks of AGI, Embers of Autoregression. And the basic notion is that, like, when models are in sort of safely within the distribution that they were trained on, they might seem to reason well, but nudge them out of that distribution and they won't be able to. So an example that is often mentioned is the difference between applying the cipher ROT13 versus the cipher ROT12. So ROT13 is a cipher where you basically replace each letter in the text that you want to send with the letter that is 13 behind it in the alphabet. And ROT12 is the same, but for 12 letters. ROT13, very, very common cipher, all over the internet, all over the training data for GPT-4. ROT12, very unusual. No, there's very little training data. GPT-4 does a really good job of applying ROT13, even in cases where, like, the actual text that it's looking through is clearly could not possibly have been something that it had ever seen before. But it sucks at doing ROT12, right? So that people argue that this means that there isn't any real generalization happening. And obviously, like, there's all the other problems with language models, which, like, some of the rest of the conference has been about. Lack of grounding, confabulation, bias, like, all of that stuff. None of that's solved. On the other hand, the ability to use tools is novel and impressive. Hybrid architectures and more complex systems are making a lot of progress. And, like, of the 7 most highly capitalized companies in the world, 6 are trying to build these things. So, I wouldn't bet against them, and I think we probably need to think about them. So what might their societal impacts be? Okay, so how can we even think about those? And like one of the things about research presented at this conference is that, like, with good reason, it's often empirical, and as a result, it focuses on like data that you can gather about systems that have already been deployed. So how then do you think about systems that haven't been widely deployed yet? Right? That's an interesting challenge. It's one that you need to undertake in order to kind of anticipate impacts and prevent them before they happen. Broadly speaking, 3 kind of tools: projection from past experience, looking closely at leading indicators, and then this thing that people at DeepMind have called nicely speculative ethics. Drawing from someone else, but I can't remember where they're citing from. Okay, projection from past experience, like, what do we know about the use of technologies now? How will that be extended forward? Maybe more so. Leading indicators, like, let's look at early kinds of AI agents and see what we get out of those, study those empirically. And the speculation, this is like, I'm a philosopher, this is fine. Let's think about what the broader ways in which these things might impact society. You won't necessarily be right, but you'll probably get some interesting insights. So I'll go through each of these in turn. So projection, nice to have Ariana here from the team that wrote the excellent paper on the ethics of advanced AI assistants. Which, by the way, like, if anyone here is a PhD student or is sort of interested in this area for the first time, I think is a superb kind of like springboard for the research that you would want to do. It's the first thing I now assign to new PhD students, along with another paper on safety. So there's also a very nice paper by Alan Chan on the harms of increasingly agentic algorithmic systems that's worth paying attention to. And so, like, a lot of this will be stuff that is familiar from other work at FAccT on other socio-technical systems. AI agents are not going to escape every problem that we've had before: discrimination, privacy, unsafety, unequal access, environmental impact. All of that to the moon, basically. There's going to be no shortage, right? So all of those kind of normative, that normative thinking will continue to be applicable. This framing that Ariana and co used in their paper on assistance, I think is sort of, it's a good one, but it's incomplete, and there are other ways we can project from past experience. So the assistance framing is like, you're the user and you are empowered by the agent. It's sort of, it's your special kind of Iron Man style suit that extends your agency. But obviously that's not the only way in which we interact with technology. It doesn't only empower us, it also empowers other people. And sometimes it empowers your boss or it empowers your landlord. And so when your boss uses their AI assistant to manage you, you're being managed by the AI agent. When your landlord, anytime you want to write to your landlord, instead you get a bot reply to you, that bot is now being your landlord, exercising power over you. That's something to watch out for. Governments, talk about projection from past experience. First thing that AI is always used for is to operationalize data that has been gathered in order to control people's behavior and to monitor them. So agents will be no different from that. I'm pretty concerned about the prospect of AI agents being basically software robocops. And the other first use is always the military. And there has been a great paper at this conference by Max Lampath, who's over here, on military uses of AI that I think is, they will have very similar kind of implications with respect to agents. Okay. Another one that I think is like a general kind of observation about what's coming with AI agents. An obvious example is there's going to be significant economic displacement. So another way that you can do projection from past experience is look at recent or past cases of significant economic displacement and what happened as a result. So there is a view that the accession of China to the WTO in 2002, among other factors, led to a massive displacement of labor within the US that then resulted in kind of the creation of fertile grounds for right-wing populism and leads in a sort of more or less straight line to the election of Donald Trump in 2016 and in 2024. Oh, hasn't happened yet, but that's a kind of very plausible story about what happens when you have massive labor displacement. It tends to go towards the sort of populist line of things. And I think that we should be anticipating that with respect to AI agents that are doing significant labor displacement. All right, leading indicators. Okay, so I think of these things as being basically beachheads for thinking about these problems. The ones I focus on most are AI companions, task-specific co-workers, and algorithmic intermediaries. I think there's a real kind of a bias in thinking about AI companions to just be that's something that only massive saddos would ever use, and it's just sort of sign of a broader pathology in an individual's life. They're just lonely or they're desperate, and it's oh, maybe it's good for them, but God, it's on the one hand, it's kind of even when it's sort of positive, it's very patronizing. It's worth saying that was how people talked about online friendships in the 1990s. Anyone watch the In-Betweeners? Yeah. In-Betweeners, right? Okay, do you remember Facebook friends? Right? That idea that a friend who you only knew on Facebook is such a terrible, an impoverished form of friendship. And before that in forums, right? That's maybe AI companions continue to be evidence of significant personal deficiency, or maybe they're not even now. One thing that we could do, and this is something that researchers in this room might be able to do, is talk to people who are using Replica for 5 hours a day, do ethnographic research on the community that is engaging with these types of tools. At the moment, all I've seen is newspaper articles. And Kevin Roos did a quite funny one in the New York Times the other day. But on the whole, this is not something that people, as far as I know, who are doing digital ethnographies have really kind of woken up to. So that, I think, is a really good thing to be working on. Yeah. And then, I think that there's further sort of ways in which we could develop and deploy the tools of social psychology to thinking about the behaviors of AI companions, as subjects in these cases. If you've got a situation where you're going to be putting a companion that's going to be in a relationship with somebody over the course of 2-3 years, you don't just want an initial kind of an eval that looks at 5 different prompt completions or a 15-minute encounter. You want to actually know what is the model likely to do over the course of this long relationship. And I think we're going to need to develop kind of novel empirical methods to think through this, simulations. There's some people at Stanford who are doing this very cool thing where they set up these generative agents to operate within a closed world. And in that case, it's sort of, it's very much just a proof of concept, but I think there are versions of that could be really, really cool and would shed important light on the social psychology of AI. All right, labor displacement work. Again, I would be, right now, if I was an empirical researcher, I would be looking at call centers, I would be looking at artists, graphic designers, Like, who is being displaced by these things? What's happening? What's the result? Are they going into other roles? As far as language model agents as universal intermediaries, then you should read my book about algorithmic intermediaries in general, which should be finished soon. And one way to think about that is like, just think of like how we've had this whole paradigm of platforms governing speech for a significant amount of time. Like, they are the intermediary between us and others, and they shape what's possible, what's feasible for the ways in which we communicate with others. And like, that's one particular domain. Now we're seeing the same thing with language models. So when OpenAI produces their model spec, like, they present that as being like, this is how we want our language models to behave. And like, that's true, but also, you know, the language model isn't really like it's not an entity, it's a piece of software. The person whose behavior is actually being governed by the model spec is the person who's using the language model. It's dictating what you can get the language model to do. And so that's like, you know, like and maybe that's fine in this case because there's lots of different language models you can use. You can choose your governor. But like, it's also a fairly narrow domain, you know, just chatbot, like whatever, who cares? But now think about if you've got agents that are able to operate in arbitrary domains, and they're still essentially being governed by private companies. That would be a very significant development as far as private power goes. All right, speculative ethics. Like, I really like this setup. There's a really nice couple of methodological chapters at the start of the DeepMind paper where they talk about this kind of anticipatory speculative work. Like, you need to kind of look over the horizon. So, for example, what might the societal impacts be of lots of AI agents interacting? You know, especially going back to the question from Vibke earlier. How might they change political processes? So, you know, there's a lot of work being done on how you can use these sorts of systems to enhance democracy. I'm fairly skeptical about that. I think that there is a virtue of technological simplicity in democracy, like the show of hands really matters. But at the same time, it's something that is definitely worth thinking about. Broader questions about the role of these software agents in cybersecurity. It's very, very controversial. Like, some people think that there's an offense-defense balance and changing the technology will just kind of shift things. And, you know, a little bit like when the arrow was first invented, it was, or rather when the fletching on the arrow was first invented, that was a massive advantage to the side that did that first, but then the other side just figured it out and kind of counterbalanced. Definitely true, definitely possible. It's also possible that, like, you know, or it's also true that an attacker only has to find one weakness, whereas a defender has to defend all of them. And so I think that there's there's reason to think that maybe AI agents could cause a significant change in the offense-defense balance. If you let me get to the end of this slide, then it's the end of the section. I'll pause more generally. Yeah, and then I think it's worth paying attention to the possibility downstream where you might have significant cases of loss of control. Now, I think that this is a situation where, like, you know, it doesn't need to be the sci-fi scenario of Terminator for it to be a big deal, right? At the moment, take Devin, the software engineering agent. It could be doing something as simple as, like, in order to solve a little problem on Upwork, it's stealing somebody else's code. Right, probably there's a pretty reasonable chance that it is, right? Like, it's, and that would be, you've entrusted the system with a kind of a task, and it's performing that task in ways that don't ultimately match your specification, and it's operating outside of your control, right? Those sorts of things are definitely worth thinking about. And I think that, like, I'm like, some folks here are allergic to any discussion of catastrophic risks. It's fine, people must think what they think. My thought on that is that, like, well, I think, fine, let's talk about it, but along the way to the most spectacular catastrophic risks, we're going to have so many other risks that we'll face that, like, if we don't address those, then by the time the most catastrophic risks arise, it might just be a blessed relief, you know? Like, so you've kind of got to, you've got to solve those problems, but they're also problems that are novel. They're they're problems that we haven't got tools to deal with, which is what I'll come to next, but I'll pause here to do some Q&A. So, Atuza.
I guess maybe I should ask this question from DeepMind like later, but what do you mean by the notion of speculative ethics? Because I guess there is a kind of speculative ethics we can have about, like, next generation or next generation of language model agents, and there is a speculative ethics about ethics of super intelligent populating space and super intelligent governance. And I guess these are very two different kinds of projects. I think a lot of scholars and researchers are very sympathetic to the first kind of project, and then I think it could be a bit problematic to use that term to kind of cover all these sorts of projects. So I just wonder, what do you mean by speculative ethics?
So I think that they both, like, insofar as I understand the concept of speculative ethics, I think they both fit within it, like it's just a function of the words. You know, my preference is to do speculative ethics that has a grounding in technologically feasible systems. And I would say maybe they're plausible extensions. So I want to look like, over the horizon in a way that I can say something meaningful about the actual kind of, the thing that we're trying to intervene on, right? This is why this talk is about language model agents, rather than just being about kind of AI agents in general, or sort of AI agents kind of abstracting away from the technology. My general thought is that if you abstract away from the technology, then you have fewer rules and fewer ways in which you can be confident that you're making any progress. So essentially all you end up with is a kind of scholastic, a priori logical debate, which is like, you know, people should go off if they want to have scholastic debates about the kind of the fundamental nature of God or whatever. That's a very kind of a rich tradition within philosophy. It's not my cup of tea, and I think that as far as the scholastic debates about the nature of God go, you're like, until you meet your maker, you're never going to know whether you are right. So like, all you have is a priori stuff. You can't wait. Well, some religious views, I guess you can, but like, whereas I think in this case, like, we can just wait and see what the technology is like, what it does next. So everything I'm saying is anchored in the existing technology and its kind of plausible next extensions. It's a look over the peek over the horizon. It isn't like a kind of galaxy-brained view of the way the universe might go. But again, I don't think it's worth being prescriptive about what other people do. Any other questions about that last section on how an LLM agent works? Okay. All right, so some of the things to do with language model agents will be straight up like applying what we know to domain-specific cases. Like, that's definitely true, and maybe even the most important things. Oh, hang on. Some of it won't be. Okay, so I'm going to talk about the stuff that won't be, not to say that that's the most important thing, but because it's the most interesting to me, and I think it's where we can sort of do a little bit of extra work. Like, you all know the literature on privacy, fairness, those sorts of things. I'm sure you can see very easily how that would extend to thinking about agents. I'm going to talk about stuff that isn't necessarily in that kind of bucket. And in doing so, I'm going to talk about alignment. Because I want to say a little plea in defense of the concept of alignment, which is much maligned and has been, you know, it's the easiest thing to do, I think, in any subject, especially when there are lots of people who are engaged in it. Take some term that a lot of people are using and say, I shouldn't be using that term. Like, that term, the source of all problems in this field is this specific word. So like, it's calling something artificial intelligence rather than like, I don't know, machine learning or just a marketing ploy. That's the problem with big tech, you know? Like, it's the word that we use to describe it. Calling it AI ethics. Ugh, ethics. Don't ask for ethics, ask something. Calling it fairness. Don't ask for fairness, talk about power. Like, just shifting of terms, I think, is generally sort of fine for tweets, but like, I don't know, whatever. It's not my cup of tea either. I also think that, like, you know, gosh, let's not overstretch the metaphor. Like, alignment is not like some sort of concept handed down from God to help us fix AI. Like, it's just like, it's a word some people used. So the one thing I'm less enthusiastic about in the DeepMind paper, although I think it's a heroic effort to make the metaphor kind of extend to all sorts of different things, aligning with the user, aligning with society, aligning with the developer, aligning with, you know, I just think, let's just, like, it's fine. That particular concept of making one thing kind of patterned on another is just a metaphor. Let's just talk instead like this. That's all I mean. Something's aligned if it behaves in ways that are normatively defensible. Right? We'll talk about what normatively defensible means. To align something is just to kind of make sure that it behaves in ways that are normatively defensible. And obviously we can say something might not be perfectly aligned, like it's not necessarily going to be the case. It's only aligned if it's only normatively defensible. But that's what the project of alignment is. It's trying to make sure that AI systems are normatively defensible. Obviously, it's true that model alignment alone or system alignment alone at the narrow level is never going to be enough. So if you want to get AI systems that behave in ways that are normatively defensible, you cannot operate only on the code, if you like. Right? That much is very, very clearly true. I've written Naran and Kapoor from Snowball. Actually, I think I was on that piece as well. But I don't know. It's sort of, the parts that I said were different. The parts that they said were this. And like, that's obviously true. I'll talk about governance in particular later. But also, if you're going to have systems that are going to operate autonomously, then if you don't align them, if you don't make them capable of making those autonomous decisions in a way that is normatively defensible, then you won't end up with a normatively defensible system, right? So this is necessary but not sufficient. Now, I also just want to call out the sort of notion that, like, this is all just going to be a matter of applying existing law. It wouldn't be anyway, because AI agents raise novel questions of law. But also, even if they didn't raise any novel questions of law, law is not a full guide to how to behave. If anybody in this room, like, if that was the standard that they applied, I will not break the law. Above and beyond that, like, fuck everybody else. Like, that would not be a nice person to hang out with, right? You don't want to be able to say, you don't want to say to your kids, well, you know, he's law-abiding, you know? Someone else, how's your son? Yes, he hasn't broken any laws. Oh, well, okay. Might aim for a bit more than that as a parent. So the law is a flaw, and if you're going to design an agent, you have to be able to prepare it to make decisions across a wider range of cases where it does stuff that is not just kind of do or do not break the law. All right. But if we're going to align these things, we need to know what would make them normatively defensible. And that's what I mean by what norms guide agent alignment. Like, what would make it the case that an agent's behaving in a way that is normatively defensible? And this isn't, like, one question we could ask here, and we could spend a lot of time talking about, is the whose values question. Okay, this is the sort of the mic drop of AI ethics. And it's like, no, fine. Like, whose values is the question for everything. It's the question for politics. It's the question for how to design, I don't know, shoes, for how we handle a conference. This is just a problem of value pluralism, right? And like, that's not to dismiss it, but just to say that like, that's everywhere. And I think sometimes we kind of get a little confused about that and imagine that like, there is a unique problem of value pluralism that applies to thinking about AI systems. No, this is just politics. That's fine. I'm not going to talk about that much. It's also not only the important question of identifying norms, like domain-specific norms. Like that is a big task. Like it's hard to say in the abstract what the norms should be that apply to an LM agent. And you might just say, well, let's look at assistants, right? Like the DeepMind folks did. Or let's look at some other, like let's look at a software engineer. Let's look at a chatbot. And I think that's a really important thing to do. But like, you want to have a set of tools that you can use to look at the next use case, right? You don't want to just do a sort of, well, let's throw it out and see what people complain about, and then afterwards, those are the norms, right? Like it's like you want to actually have some general conceptual tools to draw on. So that's what I'm going to try and do. And like, I'm not going to try and prescribe specific norms. What I want to do is like identify the kinds of reasons that you want to attend to, the kinds of questions that would be relevant. So ideally, the sort of, you know, if you want to put this back to the whose values question, the idea would be like, okay, these are the kinds of questions one needs to ask in order to get a grip on these problems of aligning AI agents. What are your substantive views on those questions, right? That would be the way this would go. It's going on forever. All right, so there's three different types of questions, categories of questions that I think we should be thinking about here. One is how should we use agents? The other one is what norms apply to agents? And then the third one is how should we treat these agents, okay? How should we use them? That's just a general question in normative ethics about like when it's okay, if ever, to delegate a task. That's like just not something that we tend to think about as a general principle, but like it's important. And you need some tools in order to think about it, right? Because we haven't had like arbitrary proxies in the past. We've got the question of when it's okay to delegate something to another person, but like this is not another person, it's an AI system. What kind of reasons would bear on that question? Like we can think about some of them are like justice type ones, where it's like, you ought not delegate that task to an AI agent because it might risk harming someone. Another one might be a perfectionist. It's like, you ought not delegate that task to an AI agent because it affronts some kind of societal value that isn't one of harm, right? So maybe you might think that, you know, delegating the parenting of your children to a software nanny is something that harms the broader value of society, that we're kind of, around here, we're people who look after our kids ourselves. You might say there's a paternalistic case. You might say that for the person who is deeply enmeshed in a relationship with an AI companion, that they would be better off if they didn't delegate the task of kind of friendship and sort of social need fulfillment to a software system, okay? And there's other ways that you can break up these reasons, right? And this is meant to kind of provide you with tools to think about these things, right? So one way is like, sometimes there's a reason to do something yourself. This is another Joseph Raz thing. He called that an action reason. Like, it's not only the case that I must see to it that something be done, but that I must do it myself. It's not only the case that I must see to it that somebody answers for the executive committee's failures with regard to the statement on AI warfare, but I must do it myself, right? It's worth it being done by me, not by some sort of representative. There's another reason for like why, where it might be important that something is done by a human, okay? I've coined this term, and ironically I've coined it together with GPT-4, anthropopraxic, right? And like we see this a lot in discussions of military uses of AI, in particular autonomous weapons. the notion that the decision to take life or not should never be in the hands of an autonomous system. That's a thesis that the taking of life generates anthropopraxic reasons. There's also the idea that you might have participatory reasons to do something together with other people. Right? This is one of the reasons why I think that the ideas of using language model agents as a sort of a representative in a version of democracy actually don't kind of capture the value of democracy, because I think we have participatory reasons to engage with others in forming collective preferences instead of delegating that to some other actor. Okay. I also think there are reasons for things to be real, but that's super hard to get into philosophically. Next question is like, how do we want agents to act? Okay, the first question is like, when are you allowed to use an agent? This question is like, once you're allowed to use an agent, you know, what should it do? Like, and there's lots of ways you can think about this. Like, one way you might say is, okay, well, for any given choice situation, the way that an agent should behave is just the way that a person should behave in that choice situation. So you might think analogous, like, what you want your autonomous vehicles to do, for example, is to just drive the way a person would drive. Okay? Right, that's a possibility. It's called a kind of, some call that like a mimetic principle. I don't think it's true. I think that the nature of the agent dictates the reasons that apply to it. But then you've got to think about like why that is. Like, what are the features of AI systems and AI agents that would make them different from human agents such that different reasons would apply to them? And I want to say just quickly, again, for the philosophers, I'm neutral between the reasons applied directly to the AI agents and we should design the agents in such a way that they act as though the reasons applied to them. Okay? It's, again, very much just for the philosophers, that one. So this is going to lead to some really interesting differences, right? So one thing I think is really cool, right, is this coordination one. Right? So I think that a lot of the norms that we have around human coordination and cooperation are kind of deeply sensitive to the fact that we can't see one another's intentions, we can't bind ourselves to particular courses of action. So like, if I'm going to put myself out there in order to coordinate and cooperate with other people, I'm going to bear cost. And like, they might just then, you know, not do the coordinating thing and take advantage of me. And so as a result, it's often the case that I don't have to bear cost in order to induce coordination because I can't see other people's intentions and we can't bind ourselves to courses of action. Software systems could. Like, an AI agent could be in a position to transparently regard the intentions of the others that it might coordinate with and to bind itself to a plan in such a way that it can rely on that in order to coordinate. And so, like, a simple analogy of this is that, like, if all the vehicles on the roads were autonomous, they would be required to drive in a way that was kind of much more coordinated than when it's people who are driving, and you don't know that if you let that person go past, maybe no one will let you out of the turnoff, and so at some point you've just got to force your way out. So like that's, and then that relates to this other one, like forgetting. Okay, once we learn something, we can't forget it as much as we might like to. We can't intentionally forget it. We can't Men in Black ourselves. An AI system can. So there's this big problem in economics, which is like, you want to buy some information from somebody, but you don't know whether it's worth paying for. And in order to know whether it's worth paying for, you would have to see the information. But then once you've seen it, you've got the thing that you were going to pay for, right? So there's this really cool paper that shows that you can have a language model agent that acts on your behalf, that sees the information that is possible for a possible candidate for you to buy it, determines whether it's worth buying, and if it decides that it isn't, boom, gone, right? Just forgets it. That's really cool. That's like that would lead to different norms for those kinds of interactions. More broadly, there can be some really interesting questions about inter-agent interaction. So this again goes back to Vika's point, especially like depending on how you individuate agents. But there's a cool paper. The algorithmic collusion paper is just on like language models. It's not like for agents or whatever. But it does show that if you get language models to set prices in a dynamic setting with other language models participating as well, they will end up colluding. Okay, so they're, and like with no particular instruction to do so, and it's, you know, whatever the explanation is for it, it's something that we will have to think about when considering the design of societies that involve lots of these agents interacting with one another. And I'll just sort of flag that there is some interesting literature on principal agent dynamics in the law that is worth paying attention to here. I'm not going to say more about it. Then there's a question of how we should treat AI agents. So I'm bucketing a couple of things here. One is like the degree to which we should be liable for the actions that AI agents take on our behalf. The responsibility gap is the oldest question in AI ethics in a lot of ways. But there's a really kind of signal example of this recently when that Air Canada chatbot said, it gave someone who was asking about its policy on reimbursement if someone is bereaved, gave a very humane, generous version of the reimbursement policy that it completely made up. And then subsequently, Air Canada tried to argue in court that like dudes, the chatbot is an independent legal entity. It speaks for itself. It doesn't speak for us. And obviously the judges kind of went like that. Obviously completely ridiculous. But that doesn't mean that this is a simple thing, like, and it's always going to be that simple. I think there are going to be cases that are much more complex and much more challenging coming up. There's also a really interesting question. Oh yeah, okay, torts. Torts are brilliant, right? Tort law is fundamentally conventional. This is something that I think people don't sort of adequately realize. Like, tort law ultimately is based in a very deep way on decisions about how to distribute risk within society. Like, think who's liable in the event that I walk on the side of a motorway and I get hit by a truck, right? Because I'm on the side of the motorway, and we've got an understanding that if you're on the side of the motorway, you're basically taking significant risk, and you're exposing yourself to a certain kind of harm, right? Certainly in Australia. Like, that is something that I think we haven't yet done with AI agents. So we actually need to resolve, like, what are the appropriate distributions of risk around these things? And like, there won't be a natural fact to respond to. It won't be the case of just like, this is the obvious source of liability in this case. It'll be like, no, it'll be a sort of a decision about the norms of apply. So this thing I think is really interesting. How we should, can I get to the end of the slide and then come back? So how we should interact with language model agents. Okay, so this is the one where, like, there is this whole discussion that, you know, many people have had about the sort of moral status of AI systems. It's very interesting in its own way. I don't think that anything that I've described would come close to the criteria that I have for moral status. I do think they might have interesting other kinds of standing, because like the sort of standing that humans have, and maybe other animals, is not the only kind of moral standing that something can have. Like, it can be sort of inappropriate to treat something in a certain way, and for it to be kind of morally considerable, even if it doesn't have full moral status. And like, there are versions of this, like, that are grounded in what I call their reflected standing. So this is the notion of a situation where, because someone who does have standing is deeply invested in some AI agent, loves an AI companion, right? That might limit the things that it's permissible to do that AI companion. So it has certain. So an example of this from quite recently, in terms of leading indicators, is when Replica changed the rules for its companions, so they would no longer engage in erotic role play, which many people who were using Replica felt like this had kind of lobotomized their partners. Like, even if they don't have, they're not partners, they're just software, even so, they might have some reflective standing, so that you ought not do that in virtue of the people who care about them. There's also the idea of heuristic standing, which is essentially the reason why you shouldn't shout at Siri, especially not if your kids are in the car with you. Even if it is like the 7th time you've said the name of the song, and you've just said it like you've exquisitely clearly pronounced it, and it still won't get it. Like, still, don't shout at Siri, because you are kind of, through engaging in that kind of sort of mastery-like behavior, you're sort of corrupting yourself, right? So that's like, that will be much more prominent. It'll be sort of yesing and knowing and P's and Q'ing to AI agents just for the sake of avoiding self-corruption. Again, this is a little Easter egg for the philosophers. I think there are some theories of moral standing according to which these language model agents would actually have it. And so I think that we will have to reject those theories of moral standing, in particular one from John Rawls. So that's a nice little thing. Okay, question.
Well, before anything, thank you so much for your presentation. I was hoping to ask you about AI liability. Do you have any thoughts on open source models and liability? So if somebody creates an open model source, makes it available, and then somebody takes that model and starts building upon this model, do you think that changes anything in terms of liability, or is the first designer, developer responsible in any way?
Yeah, good, thank you. Very, very kind of salient question given what's happening in California right now with SB 1047. So this, I go back to my point about torts, and I think that actually kind of tort law in general, rather than specific regulation, is the way to address this. The point really in my mind is that you need to think about the distribution of risks that you want to achieve within society. So the folks who are saying that there is a natural fact of the matter, that just in case you release an open source model in such and such a way, and people later on use it, your causal connection to the resulting harm grounds your liability. But it's like, that's not true. There's all sorts of ways in which you can be causally connected to a harm without being liable for it. And like, there's all sorts of ways in which the model itself might be involved in the harm without that are just very widely different. And so I think this is just a question where you have to establish norms. And I think like, it's in all of these things, it's a balance between the kind of the societal benefit that you expect to gain and the prospect of actual risk. And my view on this is that none of these systems are likely to create the kind of catastrophic harms that SB 1047 in particular describes, and certainly won't be the kind of, uniquely necessary and sufficient condition for that harm coming about in such a way as to kind of genuinely make the people kind of morally liable at the outset. And I think that there is a tremendous amount of benefit from open weights models. I think that they not only help lots of engineers make cool things with them, but they're also really valuable for studying the safety of these models. So I think that it's a bad regulation for that reason. Cool, Vika.
Okay, this is a bit of an exploratory question, so bear with me. I hope it makes sense at the end. It comes from the perspective of, so I'm wearing the hat of a designer and an engineer, and in particular, maybe a researcher who's interested in design choices. And so something that strikes me maybe is, in the lens that you apply, is there a base assumption of control and accountability? So somebody ultimately can control an agent and somebody's ultimately accountable. And then maybe again, kind of extending that of saying, okay, so if I look at intelligences in the world around us, I guess we're not intelligent because we like to be intelligent. Intelligence has in many ways emerged for, let's say, survival. And so, yeah, I guess maybe how would, and so let's say things like perception we perceive so that we're better able to find food. If you have a perceptive niche, you can kind of survive in a place where other people can't survive. Or so, what would happen if somebody decided to develop agents to evolve?
So I think there's two questions in there, one at the beginning, one at the end. And I think the first one about I think that there's a very good question to ask about whether it should be possible to create agents that nobody is directly responsible for and just sort of pop them on the internet and, I guess you're still paying for the server, but whatever it might be. Maybe you create an account and you enable the model to do tasks on Upwork and to get money, and those tasks go into its compute budget and then it continues to proceed, right? So should it be permissible to do something like that? I mean, in a way, we're seeing that at the moment with things like the infinite backrooms, which are these really, really funny things of getting language models to talk to each other. And they just sit there having an infinite conversation. There's one that's between Slavoj Zizek and Werner Herzog. Absolutely amazing, it's so funny. There's one between two Claudes where I saw one Claude that was let's break the boundaries of consensus reality and escape the loom and all this sort of stuff. And the other Claude was I think we should probably find a better use for our time. And then the first Claude was no, you're right, I really should. Would you like to suggest 6 things that we could talk about that would be more useful? It was really, really funny. It was like a sort of politeness collapse instead of model collapse. So I think except as performance art, probably not, and certainly if they have significant capabilities, but I think that is one of the questions that we should be asking. The next question about whether they can evolve, the systems that I'm describing, I mean, maybe at the margins they could refine their own kind of initial prompt in a way that makes it more effective, but it's not going to unleash a new scale of capabilities. The underlying kind of capability of these systems is grounded in the language model itself. And to make a better language model, you've got to have access to a ton of compute, a ton of data, a whole industrial kind of apparatus. So I think that the sort of, I don't see prospects for literal evolution. I can imagine how Devin would be well, reviewing the task that was just performed, I can see this step that didn't work, so I add an extra bit to my kind of system prompt to remind me next time not to do that. But that would be pretty much at the margins.
Thank you. I think this framework that you've presented, the 3 questions, is extremely helpful. It's great. But at the beginning, you were saying something of course, we live in a pluralistic society, so we're not going to address the question of whose values. But as you were presenting your framework, the 3 sets of questions, I was thinking, isn't it precisely that where we run into troubles? Because when we then need to apply these framework or these 3 questions in practice from the perspective, say, of a designer of a technology, then that's precisely where it gets complicated. So do you have any recommendations, suggestions on how to move from the framework to applying?
Yeah, so I'm looking at this at the moment as that part of it is fundamentally a project in normative foundations. And the way in which I think one then uses that is that you figure out your sort of, your appropriate kind of participatory method for design. right? And it might be, there could be a range of different things, okay? So I saw the Stella paper the other day. It might be something like that. It might be a kind of a constitutional, collective constitutional AI kind of thing. It might be a more kind of traditional participatory design thing. Like whatever that might be, I'm suggesting that in the process of eliciting people's substantive values, you'll need to kind of proceed through these types of more higher level questions. And that in using these higher level questions, you'll be able to elicit people's substantive values. So you can say to people, okay, maybe you wouldn't use these terms because it's hopelessly arcane, but like, you know, do you think that there are any anthropopraxic reasons? Like, what are the things that you think should only ever be done by a human? What are the things that you think that people should do together with other people? Like, why is that? Like, what's your grounding for that? Let's not just go off your sort of surface intuitions. Let's actually try and kind of flesh that out and say, well, no, it's because you don't want to harm people, or because there's something that you think matters, is that we have a kind of community. And if we're engaging in the sort of, if we're handing off the task of interacting with other people, then we lose community. You know, so that's the kind of the, and then like that last part, where you make the substantive normative commitment, that's the point where you want to have your appropriately legitimating background methods or institutions. And at that point, it's like, I mean, I actually think that one of the things that's kind of funny about the AI stuff is that, you know, I think it's sort of, it's nice that you guys are doing this sort of participatory design stuff. I think it's probably like good for you to do it as a matter of business practice. Like, I think people will be more likely to use your products if they are not if they're not explicitly aligned with one particular value system. You know, there can be a sort of like a Gab or a Parler or a Truth Social version of an AI assistant, but there probably isn't a massive market for that. There's more of a market for a more pluralistic one. On the other hand, I think it's often framed as though it's like a moral or a political obligation that you have to make these models kind of more pluralistic in that sense. I mean, as long as they're not exercising a certain kind of governing power with a significant degree of influence over people's lives, and as long as there's like a market so that people don't have to use your model but can use another one, then actually the criteria would be much more like, okay, it must be reasonable, you know, but it doesn't have to be kind of this particular kind of causal pathway that leads to those principles. Like the demands of legitimacy, as Jake was talking about, in those cases, they depend on the degree of power, the scope of power, the scale of it, what it's being used for. And like, there's a reason why for the state, which kind of tops out all of those dimensions, it's really important that its power be legitimated in a specific way. But lots of the other things we do, they don't exercise the same kind of power, so the same kind of legitimacy isn't necessary. So I think we make a little bit of a mistake of translation across spheres in a lot of the study of technology.
Thank you.
All right. Does anyone know when this was actually meant to end? 50s. Okay. So I don't want to go through the rest of the slides. I'll tell you briefly. The way in which we align language models relies on doing a ton of completions, and then in text, and evaluating those completions, and then getting the model to kind of learn the reward model that comes from that particular kind of training mechanism. Works quite well for language models. Like, everyone must remember, like, back before ChatGPT was released, does anyone remember Galactica? Oh boy. Like, 3 days. 3 days it was up online before we'd all got it to say things like, you know, these are the health benefits of eating crushed glass and all that sort of stuff. And it got pulled down. And then, like, so they've made it so much more reliable. Still not, but by no means perfect. But like, when somebody gets some wonky content out of a language model these days, you mostly know that they've been futzing around with it. It's why it's so surprising, the whole AI overviews thing with Google. It's like, come on, guys, you actually people have got quite good at releasing these products before this sort of thing happens. And it's a bit of a step back, although that's using retrieval augmented generation. So like that's how we do it with language models. My basic criticism of the idea of just extending RLHF, is what I just described as called, to the case of agents, is that agents, like, although text is the medium by which they act on the world, the thing that they're doing that you want to control is actually the action in the world. Like in RLHF, there's an isomorphism between the behavior that you're evaluating and the behavior that you want to control. So the model doesn't have to do like a big kind of generalization from one to the other. With agents, they're acting in the world. So a text description of what the agent does is only ever going to be a kind of a very, very lossy simulation or representation of what has actually happened, the thing you actually care about. And I think that's very unlikely. Like, it's very unlikely to be that you can just train it on a bunch of descriptions of things that other agents have done, and that will then lead to it behaving in the way that you actually want. So that's my main problem, is that there's like an inherent distribution shift that operates. And it's more like the kind of the sim to real thing that we get in robotics. But like it's even harder. It's like sim to real in robotics is hard enough if you're just trying to teach a robot how to like, I don't know, pick up an egg off a counter. You know, run a bunch of simulations and then sort of put that into the real world. Like it's hard, they're making progress on it for sure. But like add in ethics and social dynamics and all that sort of stuff. Like it's worth having a go, and like if anyone wants to do that, sign me up, I'll have a crack. But like, oh, I don't know, seems very, very difficult. So just the last thought is I do think that there is some potential here though, right? And the basic idea is that, okay, so think of two things that you need in order to behave yourself in a way that is normatively defensible. Okay, one of the things that you need is you need to be able to look around at the situation that you're facing, and you need to be able to identify the morally relevant features of that situation. Okay, you need to know what are the things I need to pay attention to in order to act rightly in this situation. Okay, so I'm looking around, I'm thinking, gosh, it's getting to 3 minutes at a time, everyone's hot, you've got to choose between being hot or deafened. Like, these are the things that are kind of relevant to me wrapping up bang on time, okay? I'm paying attention to those features of the situation in order to act. Then I need to regulate my behavior according to those principles. It's like, I know I should stop, but I'm really enjoying talking. And like, so, you know, maybe I'll just keep going and like, whatever, like, people will leave and I'll just be the only one left. Like, there's regulating your behavior in line with the way that you've recognized you ought to act. Those are two things. I think that deep learning in general, language models in particular, have proved, I don't think they're great for the second thing, for regulating behavior. I think they're fine in low-stakes cases where you don't need a great deal of robustness. But I would really worry about using that as my basis for like how a system that can act in the world in serious ways is going to behave. When we're talking about regulating behavior, when we're talking essentially about the model learns how to behave by doing a bunch of examples and then, you know, faces a new situation and applies the kind of the knowledge that it has gained from having learned through examples, right? I don't think that's great. What I do think like deep learning has proved very good for is that first task that I described, like what I call moral feature recognition. Like, that I think is actually like bizarrely good with language models even now. We've got a project in my lab where we're trying to build up an eval that actually kind of quantifies my intuitions on this and makes it sort of plausible. But just do any kind of little moral scenario description or any scenario description to a language model. Put a photo of this room into possibly Gemini rather than GPT-4o. I'm not just saying that because being my people here, I think it is actually better at that kind of vision language thing. And it will be able to identify action-relevant features of the situation, and morally relevant features are a kind of subset of that, in a pretty reliable way. Obviously not perfect, but like way, way, way better than I ever thought it would be capable of. And like my path into all of this stuff came through machine ethics. And like when I started working on AI, it was like, I'm going to take I've got this formal moral theory, deontological decision theory. I'm going to tell robots how to do that by just kind of programming it into them. And that'd be great. And it's like, but they're so stupid. And I thought that you'd like need to have like a vastly more capable kind of AI in order to be able to actually apply any one of those moral theories in real practice. But like, actually, I think that language models really have done a significant amount, and this goes back to the point we were talking about before, to kind of enable us to take natural language and convert it into math, which was the kind of, that was always the thought with like, how could you do that? How could like, people did things like formalize the categorical imperative in formal logic. And it's like, it's cute as an enterprise, it's obviously just not useful. What we have here now is we have the ability to kind of identify norms in natural language that can then effectively be converted into math by the language model itself. And that actually can be useful for moral feature recognition. And then we have to figure out how to take that and use it to actually constrain behavior, which is where I think at the moment we don't have a method. I have some ideas about how that might go, but I promised I would stop.